Oh, well, that's not exactly what I
Son of a gun.
said. Yeah, that's closer.
You know what, this is okay though, because,
It's okay, and it's okay for you, okay.
I mean, it's
Okay for
not,
you, I'm glad.
it's really not, but
It's okay, I understand.
can I tell you that I, for some reason, had, like, I wish I was making this up, I had nightmares about this grade. Like, this morning, I woke, like, I had legit nightmares, so it must be for test 3 that I'm gonna bomb, because
Well, that deserves nightmares, I mean, what you did there.
I know.
It does, it really does.
Did I write them on that, did I write them on this page? No,
Of course not.
you even looked,
Yes,
you even looked for me,
yes, I do.
you're such a great guy.
Well, I just
And I
couldn't
let you
believe it,
down.
I couldn't believe it, it was.
Ow. I
in
can't
front of
believe
my
it
eyes.
either.
I can't,
Oh.
no, I gotta take a break.
Man.
Well, what did you help with? Before the words, before we buried Hades, we took his paw prints. So I have a little canvas with his paw
Oh,
prints on
yeah.
it. Shadow boxy thingy with his
Okay.
favorite toy in his collar. And it's this hideous. So my friend gave it to us when she PCS. Because she couldn't take her cat with her.
Mhm.
And it's this, you love painted this thing, it was hilarious. It's this awful leopard print, giant teardrop shaped mouse thing with a tail, and it's full of catnip. And he would sit, and he'd pet it, and then he'd rabbit kick it, and then lick it. And then rabbit kick it, and then lick it.
Love-hate relationship.
It was hilarious. So, I need your shadow boxy thing help.
Okay. Let me know what you want me to do. Do you want me to like,
I don't know, that's gonna be something that we can work on after class is over, because I have a paper where 30% of my grade in my other class due in 3 weeks.
well, I don't have any shadow boxes on hand, but if you bring me one,
We will need to find one.
or I can try to
Order
find
one.
one, one of us can try to find it on Amazon. It'll be easy to find on Amazon.
Yeah, I think I need to place an Amazon order anyway.
I'm not sure who sent that.
Dr. Ewing?
I'm
Who's
busy
got-
right now, I can't do two things at once,
Okay.
so please don't talk to my back, I'll be available soon.
But once we have the shadow box and what you wanna put inside of it, do you want me to just put it, do you want me to just do it, or do you want like something on it?
I don't know, like I haven't completely finished thinking this out yet, you have the cricket thingy and all that, and
I'll look into it for you.
yeah, so I know I want his name, which was just funny. I may or may not want some of his nicknames, but those are a little inappropriate.
Okay,
You've
We
heard
put
them,
them in
you've
like
heard the
a-
list of them,
we could get creative with putting it on there.
because one of them just sounds awful, even though it was a lot funnier when.
I apologize for those materials here in your space.
Oh, it's okay.
One of those math 103 students.
Oh, I thought that's theirs too. No, I'm actually really irritated about it.
Can I be nosy? What'd you get?
I did not put formulas, I did not write out the
More
formula.
than once,
On 2 problems,
yes.
and that's what I missed.
Don't feel bad, I mathed wrong on one of them. I added things wrong. Not even like the complicated stuff, I added something wrong.
Well, so I had that problem the first test we took. I made very silly errors. So I actually, in my anger with myself, took the test twice to check my answers, to make sure that that didn't happen.
And
But I did not, on either time, for either problem, write the formula. Which is odd, because I did it on other places.
I have to make sure I do it because I have like half the formulas memorized, not all of them, of course, but I always go check them. Thank you for providing us with formula list, it's awesome.
And here I've been keeping the markers in the right trays too, doing my
No,
part.
and I let you down. I don't know why on these 2 did I not write it?
The same thing that
I
I
did
did.
like everywhere, oh, it's because it's a Z-score. Is it the same thing on both of them? No?
No, it's not. It's two different
I was
formulas.
too,
It's two
I was-
different formulas,
I was too worried about my,
numbers.
yeah. disappointed.
two more tests to
You
live.
must be so disappointed in me.
I'm not, no. I'm not, because I live in reality.
He's disappointed in me because I made a really, really stupid mistake, and I deserve
No, both of you had fantastically excellent tests.
Are you my twin? Are you my
My,
ex-twin?
Yes,
my
I am your
congratulations
Good job.
to both of you.
that. I am much happier with this grade than I am with the last
She
one.
trumped you, she trashed all over your grade.
Well, she did better on the last test than I did.
Well, not like she trashed you on this one.
Who trashed you? What?
Is it like I got -0.4.
I got -0.5.
See, I told you. She just whopped you.
That's really good.
I
No,
am,
they're
I am
great
much
tests.
happier with this test. And the really bad thing is I had the right answer because I did the formula for one, and then I wrote it out and did the chart and all that.
What did you say you put in, that F-word formula?
Yes.
Amazing.
And then I wrote it all out and I did the chart and I used the formulas.
The what?
Formulas.
Formulas,
I'm not trying to be a jerk, but the formula, writing the formula down wouldn't have changed my answer.
Oh, you
To
guys
be
are
fair.
so cute.
Would have changed your score.
I know. Touche. Excellent bird, Dr. Ewing.
Been rehearsing that one all day.
Who's our secret admirers, guys?
That's a silly question.
I
Who's
know.
who's the artiest one in this
But
room?
it was chocolate, so I was like, maybe it's
No,
Hannah.
no. Those aren't chocolate. Those are red velvet cake truffles.
Stop!
I don't normally brag,
I
but
thought we were dieting,
oh
man.
my god, they're so good.
Tony is amazing.
They're turned out real good.
Oh my goodness. Hello, sir.
Hello, ma'am.
How are you?
Hush up.
What? You haven't been practicing, I see.
No, you're right. You're right. I'm just trying to put in an extra consonant like an R or a W. I know it's in there.
There you
but I
go.
can't find it right.
Well, some
Oh,
words
maybe
of
I should have put a W.
Hush. Every
Well-
time I that rude.
How'd you do?
How'd you do this time?
99.5.
No. No way.
It's on the board.
I'm math
Look at it.
wrong. Yep.
Boy, stop. That's awesome. I'm so proud. You got
Me
that over
too.
99?
Yeah, she did.
We're ex-twins.
Yeah. She got 0.1 more than me.
Good job, guys.
Because
That's
I
awesome.
added wrong.
Nothing
I
wrong with your
failed.
score either. This
I
is
know.
a very
I
hard
mean, I'm
course.
okay with it. As long as it's not below that 70 line, I'm okay with it.
7-0.
Speed, solid eight.
I mean, once it goes past that line, I'm like, hush, you know?
Like, say it one more time.
Hush.
Crack me up.
I think I'm gonna be nervous about this next test.
Yeah?
Nervousness is
If
a
I can
healthy
write
way
those
to be.
formulas down.
It's a healthy way to be. Nervous.
We can study, it's okay.
Can I get
All I have to study is writing formulas apparently because
Well,
Yeah, just write formulas.
dumb mistake.
I apparently have to study reading problems properly.
I need you
I
to
told
like,
you. When
move
we're-
out of your house and move into mine. Like,
Is
is
that
that a thing?
Okay, 4
Move
minutes
into a
and
thing?
we'll go forward.
I
Put this
should
behind us.
Probably finish this row and put it away.
Tell us when to start.
Yeah, you're the
Where's
instructor.
Freddie and Kaylee and Stephanie?
Freddie is
I don't know.
here, Kaylee is here, their
Oh,
chef's here. I don't know where Stephanie is. That's what I forgot.
204.
I forgot the money for Stephanie.
There's no crack for you.
Well, I mean, I have yen, I just don't have dollars.
You can do it. You can do it again.
Yeah, no, it'd be more
See,
convenient
how did I
for
have
Stephanie
formulas
to
on my
use
homework?
dollars.
Counts
No
for your
matter.
homework.
The yen is
It's
a
just
little bit more.
1,000 yen for 2 boxes.
This must be Hannah. Gotta be. No?
It was not me.
See, that's what I said too. It's
I
chocolate.
just
Would
know
you
her,
believe
I
it's
mean-
me? Would you believe it was from him?
Teacher? Usually the students
Would you
get.
believe it?
No, because usually the students give the teacher something.
You're right, this time. Yeah, it's not from me. All right.
You know, you look like Adam West without your beard.
How do you know what I look like without my beard?
I seen your videos.
Your videos.
Oh,
You gave away your secret
forgot how
identity.
clever.
I know you
guys
know
are.
who Adam West was. I don't know about it.
I'll pretend I do.
Meaning me, the youngest person in the class?
You probably know who Adam West was.
I do, yes. Because my parents are older and I watched old Batman movies growing up. And they were ridiculous and awesome.
I just watch history documentaries.
You and my husband would get along.
I don't get along with anyone. Too much.
Bruce Lee
What?
was, Bruce Lee was a sidekick of, who's, the guy.
Lone Ranger.
No.
Okay, soon to go, 3 minutes.
The other show, not Batman, but the other.
You said Lone Ranger, I said Tonto.
No, Bruce, I was in Bruce Lee played the sidekick to the other guy. The long car. Yeah.
Who was right?
Umbrella.
Not the long cat. They're all gone now.
Hmm?
Just bemoaning those great cowboys with the hats.
John Wayne.
John Wayne, famous statement, he says, anyone can stop smoking. Takes a real man to die of lung cancer. Sorry. He said, I'm a man of few words. And he walked into a club one night. He saw a lady that he thought was attractive. So he went up to her and he said, I'm a man of few words. Will you or won't you? She said, my place or your place? He said, well, if you're gonna talk about it all night, forget it.
He's waiting for your reactions. You guys.
I'm waiting for more.
Tony?
Oh,
Thank you.
thank you.
Chocolate covered almonds.
I tried,
Oh, yeah?
I tasted too many of the things
Since
I
you
made.
did it that way.
Taste one more.
This is bitter chocolate.
Japanese.
Come on.
Uh-huh.
I'll get one later, get this one later. Okay, 60 seconds and we commence with our final 3 weeks.
The Green Hornet.
Aye, the Green Hornet.
Bruce
Oh,
Lee
who
was the
could forget
sidekick to the
the Green Hornet, the lantern, yeah. Absolutely right. Okay, 30 seconds and kick me off. Green Hornet. Okay, we do have to start now, so. Kelly, I put your test on the desk there, I don't know if you saw it. Your test.
Oh,
Yes, it's right there. Okay, so could you circle the grade on your test and I'll take them back, you can look at them after class as long as you want to. I'll just take them back at this time. The circle just means that you saw it. That's good. Yep. And one more, thank you. Okay, so this is where the grades break down. We got 2 people who seem to be quite serious in here about checking out with an A. And the B line is right there. So, and this is one grade in danger as to get it out of danger. So test 3 is a week from today. It's a week from today, test 3. And then test 4 will be the last day of class. The last day of class. 3 weeks left. And I'd like to point out where we're going today. So if you take your assignment sheet that you got last time, and on the back side it deals with A11, A12. So let's make sure we get that located, that assignment sheet. So, you got yours, ma'am? Freddie got yours too. So notice there's a change in that section 7.4 was moved up to be part of tonight's work, A11. And then section 7.2 will be A12, and then we will complete block 3 of material. And when we come in on next Tuesday, we'll take our test 3 on block 3 material, which will be A9, A10, A11, and A12. And workshop is Saturday from 2 to 4, as usual. So are there any questions, comments, remarks before we start? I'd like to start with presentation. And what we have been focusing on lately is the fact that if you have a population, the population has some mean that you don't know and you wish that you did know. So you take a sample, and the sample that you take produces a sample mean, which you have no reason to believe is identical to the population mean, which you don't know. But this sample mean is in a distribution of its own, which is the distribution of sample means, complete set of sample means, and that distribution will also have a mean. And the reason that polling works is that the mean of the population is equal to the mean of sample means. Now, this is the single most important result in the course. And now that we understand why polling works, because the mean of the sample means is equal to the population mean, we're now going to investigate how you present the results of your poll. Now that we know why polling works, we want to know how you present the results of your poll. You have taken only one sample, agreed? That sample you have no reason to believe it's equal to the population mean. There will be some error between the sample that you took and the actual population mean, agreed? So we want to now understand in this section today how it is that you calculate how much error there is between your sample and the actual mean of samples, which is what you're looking for. And because this is a normal curve, then the z-scores are in effect. And your sample will have some z-score associated with it. And that z-score will be related to the area. Because z-scores, z-scores represent the amount of area that's under the curve between that z-score and some other location. And that area under the curve is the percent. The percent of the total area under the curve that is actually shaded. So that means it's the probability of a random choice being selected will lie in that area. So if you say that my sample score is x bar, it's right here, then you can say that the distance that it is from the actual mean that I wish that it was is not known, but there is a probability associated with this error, and the probability of a sample occurring in this area is the area of the shaded area under the curve. So if you want to know the probability that you will generate this amount of error, then the probability that you will generate this amount of error is the area under the curve. So what we can say is that if I know this error, then I can say with this amount of probability that I am this close to the actual mean. But the way we do it in reality is exactly backwards. The first thing that you ask when you want to present the results of your poll is you ask the question, with what confidence? With what confidence level do I want to present the results of my poll? That's the first question that you ask. Do I want to present the results of my poll with 99% confidence, with 95% confidence, with 90% confidence, with any other percent confidence of my choosing? So the first thing that you choose is the confidence level that you want to present your results. So I'm going to take this curve and I'm going to make it a little larger just for the purposes of illustration. Now, this is the mean of all sample means. If you look at one sample mean, then if this is plus 1 sigma, and this is minus 1 sigma, then what is the probability that your one sample will be in that region? 68%, all in favor of 68%. So you can say it backwards. If I want to establish my result, at the 68% confidence level, then I can say that my sample with 68% confidence is somewhere in this area. Because it's a random sample, and 68% of all random samples are in that area. So I can say that my sample is within that area with 68% confidence. Just like if you choose one person height at random. If this is plus 1 sigma, minus 1 sigma, and you choose one person out of the population, can you not say that that person has a 68% chance of being in that window? Because 68% of all people are in that window. So the same is true with your sample. If you make just one sample, you can say that my sample is in this area with 68% confidence. And if it is in that area, then what is its maximum possible error? 1 sigma, agreed? Its maximum error from the true mean is 1 sigma with 68% confidence, agreed? So I say if I want to produce, if I want to give my poll results at 68% confidence, then I will say that the maximum separation between my one sample and the true mean is 1 sigma at 68% confidence. If I wanted to give my result at 95% confidence, then I could say that the maximum distance between my one sample and the true mean has a maximum distance of how much? 2 sigma. So as soon as you pick a confidence level, then you give the maximum separation of the region that will contain all of the samples at that confidence level from the true mean. So again, this separation between this maximum distance and the true mean is the error that you're willing to accept. So if you want to give your results at the 95%, 68% confidence level, you're willing to accept an error of 1 sigma. If you want to give your results at the 95% confidence level, you're willing to accept an error of what? 2 sigma. If you want to give your results at the 99.7% confidence level, then you must be willing to accept an error of how much? 3 sigma. Now that looks fine for those magic numbers. But what about the numbers that are in between? Suppose you wanted to present your results at the 78% confidence level. That means that there is some maximum error that you're willing to tolerate such that this area right here is 78%. This is the mean. Good? So, how can you find what is the maximum error that you're willing to tolerate at 78% confidence? Well, this maximum error that you're willing to tolerate is out here on the border. Let's call it X bar. And that maximum amount of error that you're willing to tolerate is equal to the maximum X bar minus the mu in the center. Now, how can you calculate what that maximum error is? Does this maximum X bar have a z-score? What's the formula for this z-score? x minus x mu,
Divided by.
x minus mu sub x, divided by sigma mu sub x, agreed? Now, this is our error, is it not?
Yeah, the difference between the mean and the.
That's right. So if we cross multiply, we see that our error is equal to the z-score associated with that maximum times sigma of x bars. Now, how can we find that z-score? Ha-ha, we have the 78%, don't we? If you look up the 78% in the body of the table, can you not find that z-score? Okay? Now, you have to be a little bit calculatable about it, because if this 78% is in the table, but the table doesn't work on this 78%, the table also includes this little ear over here, doesn't it? So can someone tell me how big that ear over there is? This is an intelligence question. How big, with what percent should you look up in the table? How big is this ear?
11,
This ear is 11%. Tony, tell them how you got 11%.
100 minus 78.
Yeah, because it's got another ear on this side, doesn't it? See this ear over here? This ear, 78, and that ear add up to 100. So that means the area in these two ears is 22. All in favor that the area in these two ears is 22? Good. So that means that this area from here all the way over is 89. So you look up 89 in the body of the table. 0.89. And what do you find for the z-score?
The closest is 0.8888. Are you good with that one? So it's 1.22.
1.22. Now, how do you find sigma sub x bar? Sigma sub x bar is found as the sigma of the population divided by the square root of n. So we're assuming that we know sigma of the population. So we've generated our formula for the error. The formula for the error is the z-score of this point. This very special point. This very special point has a z-score, agreed? We find the z-score of that point, and we multiply by sigma over the square root of n, and we find our error. So let's touch base with your book. Looking at page 360. If we look at the nauseating vomit-colored slab in the middle, we see a heading called confidence interval. Everybody find that? And there's a formula for E there. What's the formula for E? Z of our magic point, alpha over 2. That's our magic point, agreed? And times the sigma of the population divided by the square root of n. And we have just followed through on the board how that formula is created. Now I'm going to use that formula, that the amount of error that's generated is done in the following way. It all starts with the confidence level. That is the first number that you determine to arrive at your error window. So I want someone to name a confidence level for me.
67.
I don't mind. How about 86?
Okay.
So the confidence level is 86. That means that I want to be sure that the error between my sample and the mean is contained in this 86% region. So I need to know this z-score right here. Now, the first thing I have to do is determine the amount of non-confidence that I have. If my confidence level is 86%, what is my amount of non-confidence? 14%. That's called alpha. Alpha is the amount of non-confidence that you have. Now, that amount of non-confidence is divided into two parts. This is alpha over 2 over there, and this is alpha over 2 over here, is it not? So the z that you want to find is the z that gives you alpha over 2 to the right side. So once you know your confidence level, 86, then you have to manipulate that to find the z-score that's called z of alpha over 2 because it's on that point. So let's see an indication of how you do that. So let's go back to page 346. Page 346. Now, this has something in the middle of the page here. Most of you know what it is. Tony, this thing in the middle of the page is called a graph. And you see how the confidence level, 95%, straddles the middle, agreed? So that means that alpha is equal to 0.05. And alpha over 2 is 0.025, agreed? So what you have to do is use this drawing to find out what is that z-score at the critical point. It's called z alpha over 2. So here we have 95% in the middle and 0.025 on the other end. So you add them together and you look it up in the table. So 95%, then you add 0.025 for that ear all the way on the left. And you get 97.5, agree? So you look up 0.975 in the table, and what do you find for the z-score? The table's in the back of your book, last inside back cover. Inside back cover. 1.96. Now let's go back to this strange thing in the middle of the page called a graph again and see how they did it. So let's read the black print under the graph. The total area to the left of this boundary is what? Point? And how did they find that? Plus alpha over 2, agreed? 95 plus alpha over 2, you look at that in the table and you find z alpha over 2, agreed? So now we find z alpha over 2, let's go back to the page that we're working on. We know how to do that now. And use the formula that is on the board, the one that we're using, back to page 360. So we're using this formula right now in this problem. So now, working in this problem with Hannah's numbers, I need you to find z of alpha over 2 for me. What is z of alpha over 2?
93.
What, pardon?
93.
That's not z. That might be that might be the body that you look up.
The closest background is 1.09.
1.09? 1.09 seems about right, 1.09. Now, I just put it in the formula. Now, in this problem, I didn't tell you yet, but the sample size was 40, and the sigma was equal to 14. So that means that the error, the maximum error that we will have at 86% confidence level, at 80% confidence level, we are 80% confidence that the maximum error that we will have between our one sample and the true mean is given by this formula. It's equal to 1.09 times sigma, which is 14, over the square root of 40. So can someone finish the calculation? So remember, we're finding the maximum distance between the center of this distribution and the edge. And the edge is determined by the confidence level we want. This is the maximum error that we will have in this confidence level window. And what number does E turn out to be? 2.41? Sorry? Okay, so that means that the maximum distance at the 86% confidence level between the sample that we find, this is the worst case, it's all the way on the edge, the sample that we have measured, the one sample, and the true center is 2.41 with an 86% confidence level. We're 80% confidence, every 86% confident that the error between our one sample and the true mean is 2.41. We're 86% confident of that. So we can say that since we know what this sample is, we know that this true mean is within 2.41 of it with 86% confidence. So now that's getting all the main concept. Let's do an actual problem. So, page 362, example 1. Now, Hannah, what do we do before we do the problems? We read the problems. So let's go ahead and read the problem. People have died in boat and aircraft accidents because an obsolete estimate of the mean weight of men was used. In recent decades, the mean weight of men has increased considerably. So we need to update our estimate, blah, 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 blah. We obtain from these sample statistics for the simple random sample, we have taken one sample. We have taken one sample, agreed? So this is our one sample that we have taken. We have taken one X bar. And what was the value of the one X bar that we took? 172.55. Yes, sir. Ready to go? Okay, your books are in the back, so just switch out. Good. Now, we also know that in the general population of men, the standard deviation for weights is what number?
26.
Read harder, more carefully. 26, I believe you. And the size of our sample is? 40. Okay, now, what's the first question that we have to ask? You okay?
Yes, sir. That's the actual test itself.
Okay, good. So I need you to staple it with your own paws,
Yes, sir.
because there's missing pages.
This is the test.
Okay?
All right. What confidence do we want?
That's right. The first question is, what confidence level do we want to speak our results with? So what confidence level have we chosen? 95%. That means that we must find our z of alpha over 2. That corresponds to a 95% in the middle. So what is the z of alpha over 2? that corresponds to 95% confidence level.
2.94.
2 point? I thought we just did that on the previous sample. Wasn't it 1.96?
The closest thing that comes to 1.75 is 1.78.
Well, is it 9.5 that we want? Remember what we found out we had to do? What is it we have to include? We have to include that ear over there, don't we?
Half of the difference.
0.97.
Right. So what we're really looking for is 0.975, agreed? Remember? We have to include that little ear over there. So when you look up 0.975, then what Z-score do you find? 1 point what?
4.8.
Is that what we found before? Back on the page that Tony was reading for us?
Well,
Well, I thought it was 1.96.
It is.
oh, okay, never mind, my bad.
So let's go back to
Oh,
346.
1.9.
340, let's go back to page 346 again. So when we were working with 95% confidence, we found a 1.96. So let's make sure we can do this right. So everybody stay on it until you find 1.96. So Casey, did you get 1.96?
Yes.
Freddie? It's in the table, nothing to do with calculator. Inside back cover. Kaylee, 1.96? Anna?
Yes.
Okay, good. Now we use our formula. The formula is that the maximum error, okay, the maximum error,
Complete test, and then this is home.
good, so have a rest.
Oh, that's much.
Okay, have a nice rest of the day. Yeah, it's good for you to come in and do it. Now, the maximum error, we are 95% confident that the maximum error between our one sample and the true mean is, and let's find out what it is, z of alpha over 2 sigma over the square root of n. So it's 1.96 times 26 over the square root of 40. So we're 95% confidence that our one sample is this close to the true mean. That this is the maximum error that we're making with our one sample. We're 95% confident. So, nice job. See you in the morning.
All right, see you tomorrow.
Oh.
Oh, what's the homework, sir, by the way?
I can't tell her now because my head's in this.
Right,
I have to
okay.
get that
I'll
somewhere
just-
else.
I'll on Facebook somewhere.
Yeah, okay. Good, so let's carry through. This is an example, agreed? So let's read the solution on this page 362. Freddie, can you start to read the solution to us?
362?
Yeah, solution.
Requirement check. You must first verify that the requirements are satisfied. Number one, the sample is a simple random sample. Number two, the value of sigma is assumed to be known with sigma equals 26 pounds. Number three, if n is greater than 30, we satisfy the requirement that the population is normally distributed, where n is greater than 30. Requirements are therefore satisfied.
Okay, so what are the three requirements before we can use this formula? One, the sample is a simple random sample. We were told that. Two, we know the population sigma. We're told that. Three, either n equals 30, either n is greater than 30, or we know that the population is normally distributed. In this case, n is greater than 30. So we can proceed to use this formula. Good. B, A. So, Tony, can you commence reading A?
The sample mean of 172.55 pounds is the best point estimate of the mean weight for the population of all men.
Okay, now what do we mean by that? How many samples have we taken? How many samples have we taken? One.
Sample of 40.
We took one sample, right? And, Casey, what was the mean of our one sample?
172.55.
It's the only number we've got, agreed? So it is our best estimate of the mean of the population is our point estimate. It's called our point estimate. We only have 1 point. So it's our best estimate of the population. The question we have to ask is, how good is it? How good is it? With what probability can we say that it is so close to the true mean that we're looking for? So with that in mind, Casey, can you read B?
The 0.95 confidence level implies that alpha equals 0.05.
Okay, let's stop for a moment. So, Hannah, why does confidence level 0.95 imply that alpha is 0.095, 0.05? Why is that so?
I'm not sure I understand.
Okay, where did the 0.05 come from?
Oh, the,
Non-confidence.
yes.
Alpha represents the non-confidence, agreed? Good. Now, Kaylee, the next number, what is alpha over 2 then?
1.96.
Well, z of alpha over 2 is 1.96, but alpha over 2 would be half of 0.05,
Yeah.
0.025, agreed? Now, with that and the 95, we can look up in the table, and we find z of alpha 1.96. Now, this crucial sentence right here. Kaylee, can you read it? The margin of error, E.
Is first calculated.
No, repeat, the margin of error.
Oh, the margin of error E is first calculated as follows.
Continue.
Extra decimal places are used to minimize rounding errors in the confidence interval.
Okay, now, when you are generating intermediate results, you should keep 7 decimal places so that your round-off answer is accurate. If you start rounding off intermediate steps, then you have no accuracy at the end. So these intermediate results should be 7 decimal places. So now, the margin of error, E, is equal to what? So Hannah, could you read the formula? E equals?
E equals, z alpha over 2 times sigma over the square root of n.
Okay, so now let's go to the top of the next page. So Freddie, can you read again? With x bar.
With x bar equals 172.55 and E equals 8.0574835, we now construct the confidence interval as follows.
Now this is the big sentence right here. I'm going to write it on the board. First, we know x bar, true? X bar is our sample. We know that. Do we know mu, the mean of the actual population? Do we know this number?
No.
We don't know that number. But E tells us how close we are to that number, agreed? So therefore, that we can say that the number that we're looking for is no further below us than E, and it's no further above us than E. That E tells us the window. E tells us the window that the actual mean is the mean of our sample minus E, and it's the upper limit, the mean of our sample plus E. So let's take some fictitious number. Suppose that the mean of your sample was 27, and suppose your error was 4. Then can you not say that mu is between 23 and 31? Does that make sense? If the mean of your sample is 27, and you've calculated the maximum error at this confidence level is 4, then you know the mean of the population is between 23 and 31, agreed?
4
So-
down, 4 up.
That's what this statement is saying. That at the confidence level that you're talking about, the error that you've calculated gives you the lower drop that your sample could be, and it gives you the upper drop that your sample could be. So let's look at this formula here. It says mu is greater than x bar minus E and less than x bar plus E. So that's our error. in both directions, down and up. So put in the number, and what can we find? That mu is greater than 164.49 and less than 180.61 with what confidence level? 95%. So you see, with one sample point, we can make a interval bracket prediction about the mean of the population with a certain confidence level. And that's how we make our statement. We generate a window. And what is that window? 164.49 up to 180.61. And we're 95% confident that the mean of the population is in that window, based on our one sample. So interpretation. Based on the confidence interval, it is possible that the mean weight of 166, so they interpret the particular problem. Interpretation. Okay, now, I'm going to show you a couple of different ways to write that. The first way I'm going to write it is mu is greater than 160 4.49, and it's less than 180.61. This is the window. Now another way that I can write that is that mu is equal to 172.55 plus or minus 8.06. Is that saying the same thing? In other words, the mean of the population is equal to the mean of my sample plus or minus my error. So this is saying that the mean of the sample is equal, the mean of the population is equal to the mean of my sample plus or minus the error that we found. The other way that I can write it is as an interval, 164.49, comma, 180.61. So this is 1, 2, 3 ways you can write it. Same information. So now let's have you do a problem. On page 366, number 9. 366, number 9. Who's done? 366, number 9. Oh wait, that's maybe, I think that's a good one. Yeah, that's a good one. Okay, who's done? I want you to present the answer in the 3 forms that are on the board.
18.8486.
This for the margin of error.
One point two five times 16 divided by the square root of 50.
2.5.
It's 1.96.
Huh?
1.96.
Still don't get where the 1.96 came from.
This is the score. Did you do the 95% plus the 2.5% on the other side?
Okay.
Who's Tony?
I'm gonna say I don't know. I'll try this in the
not
world.
This is too good not to share. To be honest, for a second I thought it was like chocolate over strawberry or something like that. Cause I seen a little bit of the red and I was like, oh yes, and then I ate it and I was like, oh my god, it's cake. Yes.
You can't even pretend.
No,
I-
okay.
So we have consensus?
Yeah, I think.
For the margin of error?
Yeah, what did you find for the margin of error? Freddie, what's your margin of error? E equals what?
1.96 times 68 divided by the square root of 50, which came out to 18.84.
All in favor? So, Hannah, what is the first form that you write? Mu is greater than what?
Didn't quite map that far.
Whoa, what you been doing, talking? Eating?
Eating.
Well, teach me to go on break. Okay, mu is greater than what?
677.
Minus 18.
No, I don't want that. Well, what is it?
658.15,
Thank you. And less than?
695.85.
Okay. Second, mu is equal to what plus or minus what? Mu is equal to what plus or minus what? Ready?
Plus or minus 18.84.
What is x bar?
The mean.
What is the number?
Huh?
Say it.
677.
Okay, got
Plus
it.
or
Plus
minus
or-
18.84.
Right, and what's the last form? It's just the first two numbers with a comma. Good, okay, can everybody go to the whiteboards and do number 12, please? And we'll finish when we have the same 5 answers, number 12.
You have to sign in after all.
No, just.
Oops, that's not gonna work.
So why
Just a second. No, I don't like 12. I'm going to do 10. 10. Wow, look at that, awesome, intimidating. Okay, you gotta give me about another 4 feet here, so that's good, so people can get by. Okay, we're gonna do number 10. markers cost anyway? A lot, huh?
I just got no more minutes. It was in my book I last night, so.
Well, some people have finished, some people are still looking for a marker.
I don't think anybody's actually finished.
I understand.
Just having myself.
Those are amazing. I have to share the last one with my husband, and he will be upset, because I know this shit.
I was like, just don't tell him it happened.
That's what
I am
doing.
incapable of doing that.
Why don't I get a good one?
I guess there's gonna be extras, I'm just saying.
I was like, what? Split it all. I'm just kidding. None of those.
That ground's been plowed every spring, Freddie, you gotta bring your own marker.
I'm on most of them.
Ready with the marker. Any other? Oh, yeah, I think some
Okay, first thing, next class, I want everybody to raise their marker, show it to me, just like third grade. So let's check and cross-check that
I'm on most.
we have 5 consistent approaches.
154, 5, 8. So then, okay, 139. Yep. Is yours the same over there? Hannah?
Yeah.
Five. Six, seven there. Sorry.
You're fine.
Same.
Okay.
just standing over here checking your answers.
I'm like all in the way, I'm just kidding.
It's cool.
Yep, same.
So they're all the same,
Right?
all right or
All the
wrong.
same. Oh, yeah, sure.
Okay, now, what we have to learn to do, did you write your answers in all three forms?
Yeah.
Now, what we have to do is learn how to go back and forth between one form and the other two. So I put a challenge on the board up here. These are the three forms you can present your answer in. Mu is greater than x minus e and less than x plus e. Mu equals x bar plus or minus e, or interval x bar minus e comma x bar plus e. I'm going to give you this one. And from that, I want you to tell me what is x bar and what is e. Silence. Silence. I want you to tell me what is x bar and what is e, if I give you that interval. It's an IQ test. Don't worry, you have one. Everyone has one.
These,
E is what?
14,
And X bar is
excuse me,
74.
yes.
X bar is what?
74.
74. Because x bar is halfway in the middle, isn't it? So if these are two values, so x bar is equal to the lower plus the upper over 2, isn't it? Now this separation, is it not twice the error? So the error is equal to the upper minus the lower over 2. So this is how you go back and forth between interval notation and the other notations. So x bar is the average of the two, and the error is the upper minus the lower over 2. Good, so let me give you one more. 13 and 73. What's x bar and what's the error? No pencils. No calculators, big deal. So what's x bar? 43. Freddie, what's the error? Freddie only, what's the error? Let's write the formulas again. X bar equals upper plus lower over 2, and error equals upper minus lower over 2. So the error is $30. Go to break. 5:39, come back at 5:49, and whiteboard time.